Math 110 students. In our last video, we talked about vertical asymptotes that are tied to the domain of a rational function. And now we're going to talk about some other types of asymptotes you can have as well. All right, so let's go right here from our current slide. So we're talking about asymptotes. Asymptotes are lines that a graph will get infinitely closer to without touching it. All right, you can have horizontal asymptotes. These letter A and letter B are both examples of horizontal asymptotes. You can have vertical asymptotes. Letter C and letter D are examples of vertical asymptotes. You can also have what we call oblique or slant asymptotes. All right, so these are asymptotes at an angle that the graph will get infinitely closer to. And the graph of a function can actually, in some places, cross an oblique asymptote, and then in other places, it'll get infinitely closer to it without crossing. All right, so we know how to find the vertical asymptotes. Vertical asymptotes are connected to the domain. So if you have to kick an x value out of the domain, you're going to have an asymptote there. But how about horizontal or oblique asymptotes? So horizontal or oblique asymptotes of a rational function. And we're going to use this handout to help us navigate this. And you know what? I'm going to let you use this handout on your quiz and test. So print it off. It should be linked in your announcements. If it's not, for some reason, I forgot to put it in the announcements, it should be under special handouts, under content. If you can't find it, email me and I'll email it to you myself. But I should have it accessible unless I forgot. All right, so this chart is not terrible, but you do have to get used to it. All right, so this gives us several scenarios for various rational functions, and it's based on the degree of the top and the degree on the bottom. So n will be the highest exponent up top. M will be the highest exponent on the bottom. So n is the degree of the top function. M is the degree of the bottom function. If n is less than m, you will just have a regular old y equal to 0 horizontal asymptote. If n equals m, then you're going to have a horizontal asymptote equal to the leading coefficients. So the leading coefficient up top divided by the leading coefficient on the bottom. If your n, so your degree up top is one more than the degree on the bottom, then you're going to have an oblique asymptote, which will be found by taking the top and dividing it by the bottom, called synthetic division, and it's annoying, but it's doable, and I want you to buck it up and do it, okay? Probably one of the more annoying things you might find that you have to do by hand here, and I'm just going to tell you, buck it up. Come on, put on your happy smile. Life gives you lemons, make lemonade, et cetera, all the pep talks. All right, now what if your degree up top is 2 or more than the degree of the bottom? Then there's no horizontal or oblique asymptotes, and your end behavior of the graph will resemble the power function. Divide your coefficients and divide out your degrees. So for instance, let's say that your top function, let's just give us a really simple one. Let's say we've got 2x to the 4th, and down top we only have x squared. Well, this one actually simplifies totally about, or let's say x squared plus 1. All right, so then your end behavior is going to be very much like the function g of x. We're just going to take our top, our leading terms and divide them out. 2 divided by 1 is 2. X to the 4th divided by x squared is x squared. So your end behavior will be very much like the function 2x squared. And note, a rational function will never have both a horizontal asymptote and and oblique asymptote. It will only have one or the other. Now it can have horizontal and vertical. It can have oblique and vertical, but it will not have both a horizontal and an oblique. All right, so let's do it. Let's just jump right in. What is the degree of the top? 4. What is the degree of the bottom? 6. All right, let's switch over then here to our handy dandy oblique asymptote cheat sheet. Okay, my degree of my top was 4. Okay, so put it right over here in pencil because I'm not going to erase these off. So for this first one, my N, the degree of the top was 4, and my M was 6. So 4 over 6. This is an N that's smaller than that M. My N was smaller than that M. Okay. In that case, I had y equal to 0 was a horizontal asymptote. Y equals 0 was a horizontal asymptote. That was a super duper easy one. All right, let's try another one. All right, h of x equals 2x cubed plus 3x squared plus 2 over x squared plus x plus 1. My n is 3 and my m is 2. So my n is 1 more than my m. All right, let's go back over here to our horizontal cheat sheet. Okay, my n for this new one, my n was, oh, it doesn't even want to erase nicely. Doesn't want to write, doesn't want to erase. Let me get a different one. All right, my n was 3. Can you see that? And my m was, let's see if that's over. Okay, apparently I have no good erasers. 2. My n was 3 and my m was 2. My n is 1 more than my m. My n doesn't he go in? My n was 1 more than my m. So I'm here at letter 3. The degree of the numerator is 1 more than the degree of the denominator. The line equals y equals ax plus b is an oblique asymptote, which is the quotient found using long division. Oh, long division. All right, I'm going to put this whole thing up here so you can see it. What does long division look like here? Can you do it? You can. You absolutely can do it. And I'm going to do it by hand for you over here just so you can see the process that they went through. All right. And I think it's going to help you if we first think about long division. Let's take 123 and let's divide it by 25. Okay. So long division. 25 goes into 123. How many times? Oh, let's do 1230. 1,230 divided by 25. I need a bigger number. 25 does not go into 1. 25 does not go into 12. 25 does go into 123 4 times. 4 times 5, and see, I'm taking my 4 and I'm multiplying it by the 25. 4 times 25 is 100. Okay. Then I subtract that off. I get 23 left, and then I bring down the next thing. I bring down the 0. Now, how many times does 25 go into 230? I'm thinking 9. Try 9. 9 times 5 is 45. 9 times 2 is 18. 18 plus 4 is 22. And I'm left with a remainder of 5. So it goes in 49 times with a remainder of 5. Now, we are taking our top function. Ours was, top function was 2x cubed plus 3x squared plus 2. I'm going to leave a blank because it didn't have an x term, so plus 2. And I'm going to divide it by the bottom term, which was x squared plus x plus 1. All right. And all I need is an ax plus b. Let me show you what I mean. All right. So here's how you do it. Take your top term, see how many times it'll go into your top first term. What times x squared gives you 2x cubed? That would be 2x. 2x times 2x squared gives me 2x cubed. But I need to multiply this by everything. 2x times x is 2x squared. 2x times 1 is 2x. All right. And then if you remember, after you multiply it, you got to subtract it. So I need to subtract this whole thing. Subtract the 2x cubed, subtract the 2x squared, and subtract the 2x. Okay, 2x cubed minus 2x cubed, so those canceled out, which is the point. 3x squared minus 2x squared is 1x squared. And I basically had 0x, and now I'm subtracting 2x, and that leaves me negative 2x. And now I'm going to bring down the last thing and do it again. What times x squared gives me 1x squared? Well, 1. 1 times x squared is 1x squared, but I got to multiply the 1 by everything. So 1 times x is x, and then 1 times 1 is 1. Okay? Subtract the whole thing. Subtract the 1x squared, subtract the x, subtract the 1. That canceled out, 0. Negative 2x minus 1x is negative 3x. 2 minus 1 is 1. And I've got a remainder, but that doesn't matter. This is what matters. This 2x plus 1. I wanted a slant asymptote, and this is it. Y equals 2x plus 1 then is going to be the slant asymptote that this line will get infinitely closer to. Okay? All right, so let's go back here, and that's what they showed you here. And so then we came up with this, lots of thoughts about it, but this is their slant asymptote. Let's see if they'll show us oblique. Oh, they didn't show us a graph of this one so we could see it. But we could put it in on our graphing calculator if you just want to verify that. All right, Tay, one more. How about 9x squared minus x plus 1 over 3x squared minus 2? Highest exponent up top is 2, so our n equals 2. Highest exponent on the bottom is 2, so our m equals 2. So if we go back here to our handy dandy horizontal and asymptote cheat sheet, on this one, our n equaled our m. So we had an n of 2 and an m of 2. I don't know why I'm even trying numbers. N of 2 and m of 2. Well, that's not terrible. We're here at number 2. If n equals m, the line y equal a sub n over b sub n, which these are the leading coefficients of your leading terms. Okay, is going to be the horizontal asymptote. Okay, so let's go back to this guy. Oops, sorry. Let us go back to this guy. All right, well, what are our leading coefficients? 9 over 3, right? So y equal to 9 over 3, which is 3, is going to be our horizontal asymptote. Our horizontal asymptote. Lots of reasoning while that works. Last but not least, find the horizontal or oblique asymptote if one exists here. Our n value is 5. Our m is 3. Okay. Our n is 5 and our m is 3. Okay. N was 5. Why do I even bother? Why do I even bother? N is 5. M is 3. 5. That's a 5. All right. That's your n is 2 more than your m. So if your n is 2 or more than your m, no horizontal or oblique asymptotes, but your n behavior is going to look like the ratio of the top and the bottom here. So mine was 10x to the 5th. Up top was my first term over 2x cubed. On the bottom was my first term. So then that would become 5x to the, subtract your exponents, 5x squared. So my n behavior will look like y equal to 5x squared. Note, you're never going to have both a horizontal and an oblique asymptote, but you can have both you can have both vertical and slant. Alrighty, Hope that's helpful to you. You can print off that horizontal asymptote cheat sheet and keep it with you and use it on your quiz and test. If you need one, if you can't find it, email me or text me and let me know, and I'll get you one. All right, see you later. Bye. Keyword, wait, keyword, oblique, oblique, slanted, bleak, oblique. Now you know what oblique means. Bye.